Now we come up with some circuit symbols that you need to know for the exam. For example, you have this symbol. This is for a fixed resistor. So this is the symbol of a fixed resistor. Now we have this, like for example this one, giving you for a bulb. You have this one for an open switch. This one for a closed switch. This one representing an ammeter. This one a voltmeter. So just a recap. The first one is for a fixed resistor. This is for a bulb. You have a cross in a circle for a bulb. You have an open switch. You know what is an open switch? When it is open here, current cannot flow. We say the circuit is incomplete when the switch is open. When the switch is closed, so we say the circuit is closed, current can flow. Because it is closed, current can flow through the circuit. This is for an ammeter. You should know what is an ammeter. An ammeter is used to measure current. And a voltmeter is used to measure voltage, potential difference, or EMF. Now we have others. Like you may have for a cell like this. This is the symbol for a cell. You know what is a cell? You have, for example, cell in a remote control of your television. You have a cell there. Now you have to draw the symbol like this. The long bar is for a positive terminal, the shorter one for the negative terminal. Then for a battery, you can draw like this. You have one for positive, one negative, dot, 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 positive and negative. So this represents a battery. Or you can have several connected together, forming a battery. So here you have three cells connected together that forms a battery. Now, you should be able to draw these symbols to identify the positive terminal and the negative terminal. And when I place one after the other, I should know positive, negative, etc. Now, when you have these symbols, you have to be able to know the total voltage that can act. For example, here, I have a cell. Positive here, negative here. Let's say the EMF. EMF means the electromotive force. It is 1.5 volt. So EMF, voltage, potential difference, the unit is volt. So I have a cell here of 1.5 volt EMF. So the EMF is 1.5 volt. Now if I place three cells in series. So this is three cells in series. Series means I have positive, negative, positive, negative, positive and negative. They are connected one after the other. Positive here, negative. For example, if I draw it in the usual way, if this is a cell, you know that when you have this is positive, this is negative. I play the other one like this. This is positive, this is negative. Here you have two cells in series. Okay, so these cells are connected in series, one after the other. This is for two cells in series. Here we have in terms of symbols, but three cells in series. Let's say this is 1.5 volt, 1.5 volt, this also 1.5 volt. So if you are told to calculate the total EMF, it becomes 1.5 times 3, and this gives me 4.5 volt. So I have 3 in series, I have to add 1.5, 1.5, 1.5. So 1.5 times 3 gives me 4.5 volt. So this is for 3 cells in series. Now, I'll be placing the cells in parallel. Parallel means if you have cells like this, you have positive here, negative. Again, I have positive here, negative here. If I connect the positive to the positive, the negative to the negative, so this becomes a parallel arrangement. So in terms of symbols now, you have negative on the left, short bar here. You have Positive on the right, negative here, positive there. I connect them like this. And then I connect them in parallel. Positive, negative. Just see the difference. In series, we connected positive, negative, and so on. In parallel, the positive is connected to the positive, the negative terminal is connected to the negative terminal. Now, if I have 1.5 volt here, 1.5 volt here, the total EMF becomes 1.5 volt. Here, you don't need to add the EMFs. When they are in parallel, it is equal to 1 outside. Even if I place 10 in parallel, the total EMF will be 1.5 volt. The advantage of placing cells in parallel is that the cells last longer. The cells can provide a larger current. So this is additional. You have to know, for example, if I place in parallel, what are the advantages I can get? So the cells last longer, you get a greater current. Okay? So these are cells in series, parallel, how you calculate the total EMF. I gave you some symbols of the component you'll be using. I've shown to you how you calculate the total EMF of cells placed in series and cells placed in parallel. Okay? Now we'll use a symbol to set up circuit diagram. What is a circuit diagram? Is simply we take the different components and then we join them together, we connect them together in a circuit. Now, for example, if I say I have a cell in series with a closed switch and a bulb, a fixed resistor, and an ammeter. So let's say, for example, I have to draw a circuit diagram where I have a cell connected in series with a closed switch, a bulb, a fixed resistor, and an ammeter. So how we'll draw this circuit diagram? It's so simple. I start with the cell. I have one here, one cell. This is the positive, this is the negative. Okay, this is exactly the cell. Now I have a closed switch. Usually, the switch is placed next to the positive terminal. So this represents a closed switch. And I just told you that the switch is usually placed to the positive because it is for safety reason that we place the switch to the positive terminal. Then I have a bulb. Like this. So I have a cell in series with a closed switch. Series means connected one after the other. I have the cell, I have the closed switch. Now to form the circuit, I have a circuit diagram. It should start from positive and ends at negative. That's why when connecting, I place the switch. I don't continue like this because I have to return to the negative terminal of the cell. So I have the positive terminal of the cell, I have the closed switch, I place a bulb in series, I have a fixed resistor in series, and an ammeter. These components are all connected in series, one after the other. So I have the cell, I have the closed switch, I have the bulb, I have the fixed resistor, I have the ammeter, all connected in series. Now, if you are to draw arrows to show the direction of current, now you know that current, the symbol is capital I. Okay, you know the definition as well. You must have done current is a rate of flow of electric charge. Okay, it is a rate of flow of charges of electric charge. So the current flows from positive. I put capital I for the symbol of current. Current flows from the positive terminal, comes here, here, and returns to the negative terminal. Remember, current always flows from the positive terminal, go through all the circuit, and returns to the negative terminal. So these letters I, capital I, and the arrows show the direction of current flowing in a circuit from the positive terminal to the negative terminal. Now, in series means one after the other, I have connected all, okay? Now, somebody could have placed a bulb here. It is also good because you have the switch, you have the bulb here, you have the resistor. You can place the ammeter here, the resistor there. Doesn't matter. In series, there is no restriction. You can place one after the other. I have written fixed resistor first, ammeter after that. But I can change position. I can place ammeter here, resistor here. I can place bulb here, I can place bulb as well here. They are still in series. Now, if you are to include a voltmeter to measure the potential difference, to measure the voltage across the bulb. So what I do, I place the voltmeter here. Just see. Ammeters are always placed in series. You can see here the ammeter is in series. But the voltmeter is always placed in parallel. I told you a few minutes back that I have to measure the voltage, the potential difference across the bulb. So across the bulb is here, this is the bulb, I have to measure the voltage, so I have to place the voltmeter in parallel. Voltmeters are always placed in parallel. Now, instead of here, I can place it here as well. It's the same thing. Either I place it above or below, the voltmeters, they are in parallel. So remember, ammeters always in series and voltmeter in parallel. Ammeter measures current, voltmeters measure EMF, measure potential difference or voltage.